Now let's continue with a quiz on exploration-exploitation using the Softmax policy. The Softmax policy is again given here. The parameter beta is fixed. The question is the following. Suppose you have three possible actions, A1, A2, A3, and you use the Softmax policy. Then the following is true. You have three values. Q of A1 is 4, Q of A2 1, Q of A3 0. Then the preference for action A1, obviously A1 is the best. The preference for action A1 is more pronounced than in a situation where you have Q of A1 34, Q of A2 31, Q of A3 30. Please pause the video and think for a moment before I give the answer. And the answer is no, this is not true. Why is that? Because only the differences of Q values matter. So you take the Softmax formula here again. We divide by Q of A1. We divide by this term here, e to the beta Q of A1. Then the sum runs over everything, including Q of A1. So we have a 1 plus, then all other actions, and then you see here that only the differences matter. And since the differences are the same under the conditions spelled out here, that means no, there is no difference in values Q of A1 4, Q of A2 1, Q of A3, or if the same values are shifted upward by a constant of 30. And here is the final quiz. We focus here on the Softmax policy. Now, we initialize all values. We have two actions. Both are initialized at 0.1. For the first action, we have a small reward. For the second action, we have a bigger reward. Both rewards are between 0 and 1. Both rewards are of order 1. That is important for the argument. And then we update iteratively with our delta Q update rule that contains a parameter eta, and this parameter eta is 0.1. Now we use Softmax. As a reminder, Softmax is this formula down here that I note with a star, and it prefers an action A prime, which has a larger Q value, and beta is a parameter. And now we play with two parameters, two values for beta. The first one is beta equal 10, and the second one is beta equal 0.1. In both cases, we initialize at a Q value 0.1. Then we do 100 update steps for each action. And then we ask, how often is action 2 chosen? Action 2 being the better of the two actions. And so the first claim is, if we use Softmax with beta equal 10, then after 100 steps, action 2 is chosen almost always. Is this correct? Yes or no? Second claim is, if you use Softmax with beta equal 0.1, then after 100 steps, action 2 is taken about twice as often as action 1. Is this correct? Now you have to take out a pen and a pencil, pen and paper, and just do a couple of estimations. Don't think of an exact calculation, just a couple of estimations. And we pause the video for that time, and then I give the answer. And the answer is here. Yes, the first one is correct, because after 100 steps, we can assume that the Q values, the estimated Q values, are very close to the real ones. The real ones would be 0.5 for action 1 and 1 for action 2. And then if I multiply with beta equal 10, I get a value of 5. Okay? But e to the 5 is a big number. E to the 5 is a very large number. So yes, this is correct. Action 2 is chosen almost always. Now for the second one, it's a bit more complicated. We have beta equal 0.1. Again, we have 100 steps, so we can assume Q of A2 minus Q of A1 is 0.5, but then we multiply with 0.1, so we get a very small number. E to the 0.05 or 0.1 is a small number. So this is 1 plus, and then we do the expansion, beta Q plus, and so forth. So it will not be beta delta Q, and so it will not be twice as much, it will just be slightly as much. They will be taken with about the same probability.